who give you a presentation on AVB laser data transmission and content generation of the future. Laser projectors and controls tailored to your needs.
Meinst du? Okay.
Ja. Ah ja.
Du musst vielleicht nur gucken, wenn ich jetzt am Mikrofon vorbeilaufe.
Hey everyone. So we are Richard, the sales director of LaserAnimation, and me, Moritz. I'm a research and development engineer. Software engineer, and today we are going to talk about AVB, laser data transmission, and how to generate content with it in a way that is future-proof.
Yeah. Welcome everyone, also for myself. As Moritz already introduced, Richard, handling all the sales, mainly at LaserAnimation Solingen. So today, the first thing is going to be talking about the evolution of laser control technology. I guess every one of you might have started what I would call traditional setup. Basically, where we came from, ELDA cables, I guess, has to be everyone's nightmare, at least the one or the other time, to get them through or out of truss. That was a true nightmare. Beside that quite sensitive connector, we had also a couple other problems, limited distance, prone to interference, and so on. The other topic being our output software or output hardware, our LaserGraph TSP being, in our case, hardware locked with a certain limited flexibility. Okay. And the third point being static file format, which is rigid with pre-rendered content, so not prone to live or real-time modifications. The future, or let's say the paradigm shift, is getting away from former ELDA cables to now network cables or network technology, from hardware boxes, DACs and so on, to intelligent devices, so basically transferring the intelligence from your computer hardware, basically into the laser projectors. So for those of you who have worked with our devices, you know, you get way more than just a single laser projector. They can do way more. And basically, our other shift is going away from static ELDA files or static files to dynamic audio streams. We'll later explain you basically why and what is behind this idea. The future now, and also why this matters right now, is that a couple years ago, a big production was 5 to 10 units. Nowadays, modern production, they can easily get 100 devices or more. Here you have a picture that was during testing. So these were batches of 32 units, which were QC'd at a time. So you can imagine if we would have to plug in ELDA cables all the time, that would cost quite some time. So here is one of the advantages of running everything through network. Also, we have more and more complex synchronization, which also requires for better integration into networks. Beside this, there's also the demand for flexibility, redundancy, and what I mentioned, real-time control of the units. And finally, last point, a couple years ago, the laser guy was doing his stuff, the video guy was doing his own stuff, and so on. Nowadays, we try to having an integration with other media, such as audio, video, light. There already you see audio, video. Well, if I just add bridge, we get our AVB, what we're talking about. So basically, you have to think of AVB as replacing not just the cable, so replacing an ILDA cable by a network cable, but the entire philosophy of how the laser systems communicate with the laser source, the data source, and the laser itself. And it's here basically where that intelligent network backbone comes into action. The first question is what I mentioned before, well, what is AVB and why should you care of? The problems we have now, before ILDA cables in large productions, it gives you a cable chaos, signal degradation, no redundancy, and so on. And the other option is, well, how do you control 50+ laser projectors reliably in a stadium show? Here, in a small value, we could draw ILDA cable that would still fit. In a huge stadium, it's a no-go. Now, the idea from Michael Sollinger when he first introduced the AVB part, or that thinking was, what if we treated laser signals basically like high-quality audio data? The main idea is when I'm asking you, what is a laser show? It's XY, 2 scanners, and laser sources, RGB, or maybe with other colors. So it's finally 5 signals which are being transmitted. For sound people, they would just say it's a 5.0 sound system. So the opportunities that we have with going on AVB or treating laser signals like audio data is we can reuse existing architectures or infrastructures, tools, transmission protocols. So we don't have to reinvent the entire network. Beside that, we also have a data richness beyond ILDA. So ILDA, well, they have defined that standard, has been defined close to 40 years ago, 35. Well, there's a fun side note. Michael Sollinger was basically the person who proposed the current ILDA protocol to the ILDA 38 years ago. But as I said, they said XY, RGB, then they included some custom colors, but that's it. So we, using audio signal as data transmission, we can use extra channels for extra data. And finally, the main point, normalization and intelligence. Until now, it's your computer. If you have 3 output interfaces and all the lasers are not on the same distance, you have on your computer to adapt projection zone, geometric correction, and so on for each single laser projectors. The idea with this normalization and transfer of intelligence is that you're going to just send 100% signal to all the laser, and finally the laser itself, with its embedded intelligence, will do all the recalculation and real-time geometric correction. So what is AVB? Why should we care? The solutions is, well, as mentioned before, AVB, audio-video bridging. So you have to think like Ethernet, but, and that's one of the most important points, quite often you're going to see AVB/TSN for time-sensitive network. That's the main point. With AVB, you have a guarantee that your time-sensitive data will arrive at the same time. Standard network protocol is already used in professional audio for years. So as I said, we're not reinventing something. We are taking advantage of existing reliably and renowned hardware solutions on the market. And for now, it's being basically the backbone for our laser data transmission. To give you a brief overview for those technical foundations, well, network topology, AVB, of course, has one, I would say, disadvantage. It requires AVB compliant switches. So, of course, if you're just using 25, 50 euro Netgear switches or something else, of course, it will not work. The best switches, in my opinion, are from Luminex. You have a screenshot that's from their own monitoring software, Araneo. You can monitor whatever you want. You have all the streams, links, and so on in the software. You can use star or even redundant ring topology, something which wasn't possible with standard ILDA. And it can or allows up to 60 streams on a gigabit line. So 60 streams means it can be 60 individual laser projectors being controlled. One other advantage of using AVB is the latency at 2 milliseconds max, and that's guaranteed by the AVB network protocol itself. And finally, well, redundancy, so multiple paths for critical shows. We have in our network, when you're going to use AVB, different participants or different people. So the question is, who will meet who? That's for those which know our products and, well, both hardware and software. This is our LA Toolbox, sort of control and monitoring software, which, when it starts, scans the entire network and will show you on top our listeners. So basically, listeners are data receiver. It can be every projector from us or an AVB to ILDA converter. On the other hand, we have talkers, so data sources. These data sources, they are just talking into the network. You can also just imagine that talkers are being FM radio stations. They just send their signal, and it's basically your radio at home by tuning on the right frequency that you can receive or not the data from the one source. As talker, we do have software solutions, hardware, RME audio interfaces, Sonnet devices, as well as ILDA to AVB converter. And for the, as mentioned, LA Toolbox, that's basically our command center. The challenge, as mentioned before, well, let's say you have now 50 intelligent network or projectors onto a network. Each one can receive multiple streams, will have its own settings. It can be own projection zone, digital geometric correction, safety features like a safety mask, different disable buttons, calibration, and so on. How do you manage this efficiently? Basically with LA Toolbox. That's going to be your mission control for all your laser projectors connected on your network.
Great. Thanks for the extensive background on AVB. We're now going into some demo of the LA Toolbox. Ah, yeah. So here I just opened LA Toolbox. I'm in this network with a Mac Mini here. It's directly connected with a network cable to one of the Luminex switches here. And with these new Macs, you just connect with a network cable. On Windows, you need a special RME interface. But here, that's pretty easy. So here I just opened up the toolbox, and we can see here on the left side there are the listeners in the network, so the devices that are accepting AVB streams, for example, projectors. And here we have the talkers, like this is my Mac, which can generate some signal, and then we have some ILDA to AVB devices that can take an ILDA to that can take an ILDA connection, for example, from a laser graph, and convert that into AVB. Yeah, so, and this works now by taking the devices, dragging them in, And yeah, and now we can configure, we can make AVB streams by just like visually dragging some cables, and we can see some information. Like we can hover over the ports to see where, like, which stream is it, which format does it have, and to which target is it connected. Yeah, let me just quickly open another project file. So I have all my devices at once. Oops. Okay. So yeah, I have already I made some connections already. Additionally, to configuring the AVB here and looking at these status information, it's also possible to look into Araneo, the software of Luminex. There you can see all the devices in the network. You can see there's quite some stuff going on, and it's possible to look at which AVB connections there are here. And these connections basically mean that there is like now a fixed bandwidth allocated between these different devices. So once the stream is established, there's nothing that could destroy it. And even if we have a redundant network, if one of the cables is removed, then the stream will reroute inside the network. Yeah, and then it's also possible with our LA toolbox to set different AVB settings. For example, there's a sampling rate for the audio. There are different stream formats, and it's also possible to say, for example, how many output streams do I need or want, and yeah, and it's also possible to configure clock sources to tell which device is the one giving the clock, so all devices are synchronized. Yeah, so that's just like the one part that the toolbox is responsible for, which is the AVB. And then with toolbox, it's also possible to configure and monitor the different aspects of our laser animation devices. And it's important to know that this other stuff happens on like normal network traffic. So you only need AVB if you want to live stream some content, but if you just want to look at the devices, monitor them and these kind of things, then it's not necessary. So here I just clicked on a device. It's a Phenon accurate. We can now see here that it's in standby. There are no errors, and we can control the state here. So let me just turn it on, and now we can see that it's running. We can see the different safety status information. Yeah, there are different tabs here with different options. I can now go into the projection tab where I can say, like, where should the content come from? It's now coming from AVB, but it's also possible to put different test patterns here. Yeah, and there are different safety features also. So we could draw some mask here, for example, to secure the areas where there are like video projectors or cameras. It's possible to configure where the projector can do single beams and where it shouldn't. It's also possible to configure our network laser disable switches. These are also network-based devices that are also just connected to these Luminex switches with a network cable, and they get their power over Ethernet. And in here, I can now assign this button to the projector. and it should be this one. And now I turn it on. If I now press the button, the projector will immediately turn off. And then it's also possible to, it just restarted automatically. And this would even work if the toolbox was not open. So the toolbox is really just a view into this network and into these devices that can act on their own, which gives you a lot of redundancy. And then one important aspect that Richard mentioned was this data normalization. So we're always trying in our streams to have the content at the full size. And then we have a feature called the digital geometric correction. Which enables us to configure zones where the projectors will project something to. So I will now select a DGC test pattern and click here on Edit. And now I get a window where I can drag these 4 corner points. And then you see that the projection of the projector will change the area where it can project to. And then there are also different other transformation settings. For example, I can like scale and move the content around. I can adjust the colors. I can set the color delay. Also very importantly, that we are trying to keep this out of our data because the projectors are the ones that know best which color delay they have. So here I have showed you how it's receiving some AVB stream, but it's also possible to let it play some content from the SD card itself. And maybe we can quickly change over to the slides.
Or maybe just before changing, as you see here, we have, let's say, up to 16 DGC options. So means you can have different zones. The one would, for example, project in corner. The second zone will just be on the screen. The third zone will be somewhere else. All those zones can, let's say, be also changed either by OSC commands or by telnet. So there's a lot of different options on how to interact with these units. So again, we try to have as much intelligence on the laser and less possible on the computer.
No. Okay, and since we are using audio for the signals, of course we also need a file to store the the finished content, and for that we need a file format which allows multiple channels, allows us to put meter information in there, which also has a lossless encoding, not like MP3, which is suited towards like human perception, but we really want the data to be preserved in there as precisely as possible, and also easy to decode on the firmware. And we just want a format which is well supported and adapted by lots of tools already. So we don't have to implement all the operations like manipulations like cutting files, rearranging files, looking into them. So we don't have to implement all these things on our own. So we came to the open format AIF. And here we can see an example of some data in an AIF file. On the left, we see 8 channels, and on the right side, we see how the laser would project it. So we have, the first 5 channels are just our standard X and Y, which describe the path of the scanner. And then we have the red, green, blue color channels. And this is, in this file, we just have the data for one frame, but it could also be a whole show that's contained in an AIF file. And then we can add some special data. For example, here we have the an extra channel to control a new lens in our projectors. It's called LA Brush, which allows you to dynamically change the beam diameter within a frame. So you can make brush-like effects with a different line width, almost like a painter. And other data that we usually put there are extra colors like yellow, cyan, DMX data, or also audio. Then we also have some meta information in the file telling which channel has which meaning. And we also put some markers in there, for example, scene markers, so we know where each frame starts, which is useful if you later want to edit these files. And we have some tools for working with these files and also with AVB. So we have LA Player. You can imagine it a bit like a VLC player for laser audio files and AVB. And it also handles things like timecode, sending data to visualization. And then we have the counterpart LA Recorder, which is to record AVB streams into AAF files and also send them to visualization again, also in sync with timecode, of course. Then we have LA DSP to AAF, which you can use to convert DSP and ILDA into AAF. And we also have LA Preview, which is the known visualization tool with things like scanner simulation and the fog visualization. Yeah, so maybe Richard, you can switch back, so I can just show it in practice. Oops, this was okay. So let me turn this projector back on, and now I will just open LA Player, and you can see. Let's start from 0. I will add some audio file in here, some AAF file, and we can see information like the sampling rate, the duration, what kind of channels are in here, and then here we have like different options for timecode synchronization, for receiving and sending timecode. Then we have the audio output option at the moment. It's configured to output via AVB from this Mac. And then we can also send the data here to visualization. So since this is all set up, you see we are connected. I can now click play. And let's see what's going on with the projector. It's on AVB. It's connected. Thank you. It's the wrong stream. It was still connected to the, here you can see in Toolbox it's connected to the second stream. So, but that's no problem. I can just change which stream it should go to. And now we see this test pattern. And we can also look at it here in LA Preview. And if I want to send, multiple, so also this is just like a one frame test picture, but I can also load a whole show. And I'm loading this now. This was set to the third stream now, but I will set it to the first stream, so I can play this again, and I can, when I go back to LA Toolbox, and I switch it back to connect to the first stream, and you can see it's showing this kind of show that was pre-recorded sometime. Yeah. So and then on the other side we have the LA Recorder. I have configured the AVB to back at the front of house, there's a laser graph DSP, and it's connected to ILDA to AVB. It's also one of these little boxes powered with PoE, and it has an ILDA input, and I have already configured the AVB stream to go into this Mac. So in LA Recorder, I can now, I'm selecting the sound card again, selecting what kind of data I want to take from it. And now when I click connect, I can see that I'm getting one stream. I'm seeing some levels, and I can also check in LA Preview again that something is coming there. Of course, I could also just connect this to the projector directly. Ah, yeah. Now you see it's coming directly from the DSP via the ILDA to AVB. Yeah, and now with the recorder, I have like entered some file name, and when I click record now, oops, I cannot write to this path.
Maybe just to intervene, there we see basically we have one talker, being that ILDA to AVB, receiving ILDA signal from the DSP, transferring it at the same time directly to laser, or basically the laser is listening to that stream. And on the other hand, we do have the sound card from the Mac, which is also listening to the same stream, which allows LA Recorder to record that stream. So it's sometimes for installations, that's maybe also something we're going to talk tomorrow about, how during live shows or fix installs, the programming is done with AVB signals being active all the time, because you see in real time what you're changing or modifying. And once the show is done, you can basically disconnect, or well, you keep the AVB streams alive. You run once the entire show through ILDA to AVB interfaces. You record the show, and you have the files, which allows to reduce traffic and so on.
Yeah, and I'm going to show you what we can do with these. So let's say I'm like recording some show now, and then I get some AIF file, and we can now take this AIF file, and the projectors have some internal storage, and it's possible to upload these files into the projectors. And then here in LA Toolbox, at the projection sources, there's an option called Media. And there at Media, I can select some picture. There are some test pictures stored on the SD card by default. So you see the projector is now, it's playing this on its own. It doesn't have any AVB connection at the moment. And you can trigger this. You can trigger this manually. You can trigger this by OSC. You can also change most of these settings by OSC if you want to automate something. But it's also possible to trigger this by timecode. So, and this happens with files called time scripts. It's just little text files where you say, this AIF starts at this timecode and this at this. And you can also change some settings in there, like transformations and these kind of things, or switch the projection zones. So if I select this, time script now, it's waiting for timecode. So, and we are using a network-based timecode protocol. It's just based on UDP packages. And as a source for this timecode, I could use, like for debugging purposes, I'm just using LA Player now. So if I make LA Player play, I have configured the range in which it's generating the timecode, and it's enabled to like send this timecode to the network. So if I click play now, you can see the projector receives the timecode and is playing the show. And we also have some different tools where you can see the, like for example, LA timecode, where you can see which timecode is going on in the network. Or it's also possible to see with player and recorder which timecode is being sent and where does it come from. And as I said, I'm just using this for kind of demonstration purposes with this, like generating the timecode from the player. But there are like different options to generate a timecode. Like you could use a laser graph DSP, but we also have more boxes like these. We have one box which takes an audio LTC timecode and converts it into net timecode. So you can use it to integrate it into a big production where the timecode usually comes from some Lightning or audio desk. Yeah, so that's how you can.
I think it's also something we're gonna discuss more in details tomorrow in our further presentation about the latest trends in laser technology, different ways to introduce shows or large venues, large shows, how to control them, and so on. So that's also be quite interesting to see.
Mm-hmm. Okay, yeah. So now we have seen how we can transmit signals to the lasers, how we can record them, we can store them, how we can work with these signals. But perhaps can you switch back?
Yeah. Yeah.
Okay, thank you.
Well, that was
So, but the question now is...
maybe just to finalize, basically, with LA Toolbox, you have a centralized control, plus you have your intelligent devices in the entire venue, which offers you a huge scalability for modern production. So you're not, let's say, bound to physical DACs and network or ILDA cables. There you just put your laser in an AVB network, and then you can access them from wherever you want.
Yeah, so the question is now how we can generate and shape these laser signals in precise, professional ways where you have lots of artistic expressions. And yeah, back in the days, people were using a lot of laser graph DSP. Nowadays, there's a growing landscape, let's say, of software that can generate laser and output via AVB. For example, there's Touch Designer, which is a fully fledged environment for programming multimedia applications. There's Mad Laser, a known video projection software, which is now also adapted for laser output, laser content generation. There's ILD Renderer, which is a converter for vector graphics from file formats like from Blender or Inkscape. And then there's an interesting new software called Liberation, which is where you can program timeline shows, but also you can do live shows where you trigger queues, and you can also go into these queues and like edit them with a node-based editor. So there's people that are not so deep in the content generation can work with it, but also for advanced use cases you can you have a lot of control. And there are like other options like V4 or Max MSP. And now I want to go a bit more into Touch Designer. So what's Touch Designer? It uses this concept called node-based programming, where you connect operators. Each operator generates some data or modifies some data. You can see there this little example where you have a banana. It's a symbol of Touch Designer, and the texture of the banana is being displaced by some random noise data. And basically in Touch Designer, you can connect everything to everything. You have inputs and outputs for lasers, lighting, audio, video. You have 3D rendering capabilities. You can interface with sensors, with known protocols like MIDI, OC, and DMX. And there's also a big community, also here in Berlin. They share components, they do workshops, online tutorials, and there are also meetups here in Berlin. Which chances does Touch Designer give to you laserists? So while classical laser software is often very powerful and optimized for laser workflows, it can be a bit closed into laser-specific ecosystems and lack customization, like real-time, like real-time modifications or interaction with other media. But Touch Designer, with its node-based programming, offers you to program real-time dynamic content that is beyond classical like Q2Q triggering, and you can make your content interactive for the audience, for example, via some sensors. You can build custom interfaces for you to perform a live show or for your customer to use the system. It's really easy to integrate lots of different media. Touch Designer is a media server at heart with connections, like I mentioned, to audio, video, lighting, and it has the ability to connect all of this media and have Touch Designer as the main timeline and source for your whole show. And then with the node-based programming, it's really easy to prototype content and try lots of things in a really quick time. So all of this together can allow you to expand your practice by doing things, whether it's a timecode show, an interactive art installation, a data visualization with laser, or even a client presentation. It really allows you to go beyond what's classically possible. And while this has a steep learning curve, because so much is possible, there's the strong community that is open to share knowledge. And we had we as LaserAnimation had some history of collaboration with Derivative, the company behind Touch Designer. So in 2015, there were the first experiments together where Touch Designer was generating some control data that was sent to a DSP and some installation. But it was only control data, like where some projection should go to. But it wasn't really the signal, because Touch Designer didn't have the capability then, and AVB was also not a thing yet. But in 2019, Touch Designer introduced the laser chop, the operator which converts the vector geometry to laser signal with our guidance. And this was a really good start and enabled lots of people to play with lasers in Touch Designer. But the demand for other features was growing, and also there were some bugs in there that Derivative was just not able to fix without hardware and this in-depth knowledge of how lasers exactly work. So we started another collaboration last year with Derivative, where one of their programmers came to us, and we did some pair programming for a week to improve some bugs, improve some features, and out of it came an improved laser chop for Touch Designer in general, and we also got our own version of it, in which we could implement specific features for our projectors and even more advanced features. So now we are announcing the release of LA Laser Chop. It's a laser chop for professional optimized laser content generation and touch designer. And it's not just this one. It's not just this one operator, but it's a whole toolkit containing of the LA Laser Chop, the signal generator, which has like all the specific knowledge of like how the signal works and how you have to shape the signal for different sorts of content. So you don't have to go so deep into this trickery anymore. And then there are some other plugins for sending the data to the visualization, just like I showed you with the player recorder. You can also load these DSP or ILDA frames into Touch Designer and do something with them. Then there are different helper components, which I also showcase to you. And then there's an extensive interactive documentation, which shows all these advanced features. LA Laser Chop is out now. You can just download it from our download area on the website, and it's licensed on a flexible base per number of lasers that you need. We have an online shop for it. It's online already, and the sale will start soon after we have figured out some more details, taxes and stuff, you know. But yeah, you can already download it. There's also a demo mode inside, which allows you to test it with one laser. And I want to show you some things with it now. So can you switch back?
Nope. No. Yes.
Okay, great. So let me just reconnect this one.
So just in the meantime, from Moritz to start, basically on the LA Toolbox, it's also something which helps you to understand the health, the status of all the laser in your network, which also allows quite often to do remote diagnostic. Customers just calling saying, my laser isn't working, why? Well, just go on the main screen, read, and you will quite often understand why. Maybe it has been set by a user on standby. Maybe when testing, they had the disable button connected in Office. They are now in the venue. They're using a different disable button. Well, the laser is expecting the different IP address, so not working and so on. So that main screen holds all the information to understand why is maybe something not working and so on.
Okay. So now I've started Touch Designer, specifically the file that demonstrates all these features. Let me just quickly show you a bit of the structure. You don't have to understand everything now, but just you get an idea of the structure. So as I mentioned, it's using this principle of node-based programming. There are different types of nodes for different data types. There is textures, like I can take a noise texture operator, and these operators, they have parameters that we can change, and then we change like what's happening inside there. Then we have chops. These are like channel operators. This can be data like audio data. It can be control, like single control values. And with this, we can also interact with, like we could send some OSC signal out or receive some DMX here. Then we have the SOPs and POPs. These are both for creating vector geometry, 3D shapes. These are also the ones that we will use for the laser. And then there's also text operators where you can handle text data in, you can do things in tables, like For example, if I want to know which files are in the file system, I can use a folder operator and get all the files in this directory in here. And then we can connect these operators. So these, so far, they are all just generating data, but I could also, like for this noise operator, I could take a, let's say, like a transform, and now I can connect these together, and the signal is always flowing from the left to the right. At least that's usually how you place them, but yeah. And yeah, in this transform, for example, I could rotate the texture now, or I could use the level, you know, to change the brightness. And yeah, and it's also possible to connect these operators between different operator families. So I could also say now I want the output of this oscillator going into the rotation. So you can see that it's slowly rotating now. I can increase this by changing the amplitude. And yeah, that's just as a really rough overview what these like how these operators are connected. Oh, and also there are containers for making UI. For example, here I can make I have a button, and you see every time I press it, the value shows up there, if it's on or off. And we can also use this to structure these networks that can get fairly complex. So I have made something here, and I can go inside, create something here, and then I make some output. And when I zoom out, I'm like on the level above it, and I can see the output of what's going on inside. Yeah, so here we are in this file that is showcasing the features of our LA laser chop. We have structured this into different snippets, which are showing one thing after each other. Perhaps let's go inside the basic setup here. Yeah, and it's also pretty convenient that we can make these annotation boxes and put some text in it, so you can really explore all the things kind of in an interactive way here. And you can see here that we have placed an LA laser chop, and this is connected to something that has generated a circle for us. And the LA laser chop now takes this geometry, goes through all the points, considers how the signal needs to be generated, and then generates this stream of data for the laser. And then it goes out of this component for now. And then I have also made something in this demo file that we have some shared output component. And inside here, we have a laser out component, which contains some things that you usually do, like AVB output, AIF, file export, sending to visualization software, and also debug capabilities for the signal. And this is really convenient for you to take into your own projects. And also, like for all these components that we are delivering, they will also show up in the palette window of Touch Designer under My Components, LaserAnimation Solinger, and here you have all the components which are in this toolkit, easy for access. So let's try to get this to output something. So in this component, I have selected the sound card again, said that it should output here. Let's check now what's happening with Toolbox. Should be connected. maybe I just have to restart it again. Because something with the audio device went a bit wrong, I don't know. Let's see. Ah, it was on media. Okay. Yeah.
So it's basically what you just said before. When you don't know, check on LA Toolbox, and then you can quickly see which source is currently selected or not.
And when working with these systems for a while, you will learn how the signal path goes. So in this case, we have the lasers chop generating some signal. It could be activated or deactivated. Then it goes through some audio interface. Then it goes through the AVB system of your computer or Mac. Then it goes into the projectors. In the toolbox, you can now check, for example, you have the status window where you can see the range of the input signal. So if AVB would be selected, I'm outputting something on the sound card, and I'm seeing all zeros here, and maybe also something like a scan failsafe or the DSP scan failsafety. It would mean that somehow on the way there is no signal anymore. So after a while, you will understand like through which steps the signal goes, and you have to look from the back to the beginning if something doesn't work on the first step. So yeah, now we have this like simple circle here outputting, and yeah, you should also look inside this component where you can see all the different ways explained how the output works. So for the AVB, it just goes through a sound card, through the, like for AAF recording, it also goes through some component I made. Yeah, and then we also have the visualization. So if I open up LA Preview again, I should be able to see it, but somehow, okay, but never mind now. And down there we also have some signal debugging options. So here's a component which extracts you the current frame from this endless stream of laser data, and then we have some little 3D visualization where you can see the scanner path on the X and Y axis, and the time is also put on the Z axis, so you can see where the scanner waits for some time and what exactly it does and like how many repeats it would add somewhere. Here you can see that it's like a perfectly smooth circle, for example. Yeah, so this can be pretty convenient for when you generate content and you're not sure what's going on there. So yeah, and then we also have some simple rendering of like what this content would look like ideally. Of course, there's no scanner simulation in here, so that's better to look at in LA Preview, for example. Yeah, and then let's go into another example, perhaps. It also shows, for example, how to do multiple lasers. Basically, you just use multiple laser chops, and you put all these channels after each other, and then the AVB system will group them into streams, and each laser would be connected to a different stream. And yeah, we made some improvements on generating different content here. So here I have like different, oops, it's not selected here. I have to drag this here first. Yeah, so here we have some, like the basic laser shapes that are possible. Basically, it's like a beam, which doesn't display now because of the safety. We have a circle, a line, rectangle, or like a polygon.
you can also, let's say, go back to the beam where you see, well, it's immediately shut down by the unit. If now you would open LA Toolbox on DSP scan fail, it's going to show in red blanked. The same on the main screen.
Here, then I could quickly turn it on or off in this area.
Oder kannst du aufs Main gehen? Beim Projekt.
Ah, yeah.
It's open somewhere.
No. Ah, yeah.
Yeah. The same thing here. As mentioned, that main screen contains all the information. So when I see here customers calling saying, my laser is broken, it doesn't output anything, I see, well, it's red, and it tells me immediately why. Then if you go on the safety, you change your safety window settings, and suddenly customer has light again. The same applies with customers calling, it's not working. Well, instead of having FB4 selected, for example, on Phanon XS or on the Pico, he had selected AVB. Of course, the laser will only do what we tell him to do. So for once using or to use LA Toolbox, that main screen is really the most important one.
Yeah. So here we were at these like basic shapes. So basically we can use these basic geometry generating operators of Touch Designer and feed them into the laser chop directly, and it will automatically generate a signal that is suitable to like project these kind of shapes in a precise way. Back in the days, like 2-3 years ago, I was making something, I had to make something like this. So for each shape, we had some custom handling. For example, for a circle, you have to overlap it a little bit and then add some soft edge in the beginning and the end. For other shapes, like rectangles, you had to manually insert the repeats in the corners. And you had to know, like you had to know how a scanner exactly works, and had to know all these different parameters, and you had to know which ones to apply at which shape. And then later in the signal chain of Touch Designer, when doing certain things, these things would break again, so you had to be really careful in like handling these things. But nowadays that's much improved with our new laser chop. So you can just input these directly. But I've made it even easier. So now there's a component which can generate you basic shapes. Like you can generate what kind of shape you want here, like on the left side. You can say, do I want them output as a line, or maybe I just want the beams of it. And I can apply some standard transformations that you would need all the time. And you can also, this makes it really easy to create different kind of shapes, and you don't have to put lots of operators together anymore, like the shape and then the different transforms. You can also chain them together to have multiple shapes in like one line instead of merging them together vertically. And also what this component does, it handles some attributes that we have introduced for lasers that allow you to customize the output even more. So like for once, of course, there's color, which I can change here. And then there are a bunch of more attributes, which are maybe best shown also in an example. So, but first again, like these attributes, they are attached to each point. So for each point, you have a bunch of different customization options, and you can set them differently. You can, they are like initially generated in the correct way in this basic shape component. But there's also a component for adding them later. And And a good example for this are perhaps corners. Because when you want to make sharp corners, the laser has to wait there, and it has to wait for a specific time, which depends on the scan speed and the angle. And with our, so out of the box, this just works correctly. So a circle is a smooth circle, but like another line has, which is like these different segments. It just has, yeah, the like sharp corners there. And it's now possible to manipulate these attributes. So, for example, there's an option whether you want things to be corners or not. So if I would disable like whether these are corners and whether the waiting time is calculated automatically, this line with the really sharp angle becomes like quite rounded. And also similarly for the circle, if I would turn the corners on, it's hard to notice, but in some cases you see that you get like different brightnesses between the points. So that's also good to handle in a precise way. And then there are options like we can control now. I'm now selecting this other example, and here I'm controlling an attribute called the lookup factor, and that allows me to say like how strong should the corners be. So you can, and if you look behind you in the air, you can also see that if you make it sharper, you get like visible beams in the air and not just a rectangle. But which like can be interesting for like artistic expression if you have beams in the air, but it can also be a safety concern. So ideally you want sharp corners, but no beams maybe. And you can do this with another attribute. For example, the power reduction. And if I turn this on, they become much darker now, the corners, which is something that the original laser chop does not have. So what you can do with these attributes now, like I mentioned, you can set different values to different points. So eventually I can make something where I have a rectangle where the original corners stay sharp, but we have some noise displacement in the middle. And you see that you get the sharp corners and smooth lines in between. Yeah, and then there are some special features which are more or less related to our devices and which are also making a lot of use of these custom attributes that we have introduced. For example, for our LA brush lens, let me go inside here. So there is now an attribute called brush, and with this attribute we can change the diopter of the lens, and so make it, here we see the original beam, and now I can go here and make the beam super wide, so that we almost don't see it anymore, like from this distance where the projector is placed back there. And here I'm doing this for the whole shape at once, but we can also do it dynamically, like I'm doing in this operator down here, where I'm taking the z-axis and putting that on the lens. So you see the lines of the cube that are further away are like more widened. Or also we can make really beautiful things like this picture of a plant that's moving in the wind. And by the way, this is also using the new Touch Designer hops, the new operators that allow you a lot of, like even more ways to express yourself with vector content like this. And another very new thing that we have is color management features. Michael has developed an algorithm for converting from RGB colors to RGB with extra colors like yellow or cyan. And we have also implemented that in the laser chop. So for this, I will switch to a Phenon 30K, which has a yellow inside. Yeah, it's displaying now. So, and now I have this example here where I'm generating a circle again. I can pick a color, and then in the middle we have a display of how much of the other, like how much of which color line is being used. And here we just have RGB. Yellow is not used. And then in the laser chop, I can configure the wavelength of the different laser sources and the power of each, and also specify some color space that I want to work with, because RGB is not just because RGB is not the same as like any other RGB. It needs to be some base to like interpret it in like which areas we are here. And it also means that we can produce precise colors synced to other media. So if I have configured everything here, and I'm now telling a laser chop the color conversion is already active, and I'm telling it now to include the yellow channel, which this projector understands. So if I enable it, then you see we get some, like the yellow line also becomes active. And you can see that the result looks much brighter. And it's also possible to apply this to older show content that you might already have recorded, but now want to adapt it. Yeah, it's playing now. And if I would, let's move this a bit aside. I can now also switch between the file with the yellow inside and without. So at the moment it's off. And again, you see it becomes much brighter. Yep. And then last of all of the special features I want to show you are some further projection features. For example, you can make use of the different projection zones in the LA toolbox and the projector firmware by just telling with an attribute again on which DGC zone it should come out. At the moment it's not configured with this projector, but it's also possible. And then we also have features like you can do grid warping inside here. I can like open this grid here and change it, and like this is good for doing some very fine adjustments for like for example, like you need in projection mapping sometimes, and also for that you can generate the soft edges directly in the laser chop. Yeah, so it's just a quick overview of the toolkit. I will demonstrate it on 11th of October at an online workshop at the Node Institute here in Berlin. I mean, the workshop is online, so you can just join and get like further input. And they also have more resources for learning Touch Designer. So, yeah.
Perfect. Great. So that was our LA laser chop demo. Just before going on, that LA brush. We're going to also discuss it tomorrow in detail. Just for you to know, it's basically a hardware upgrade which is available for all Phanon Accurate, Phanon XD, the new Phanon XS, which is a great add-on. So, to go back at the start, we said, why AVB? Why should we go in this direction? Why this all matters? As mentioned, our transformation was to going away from physical old cable to now having intelligent network, from getting away from hardware boxes to flexible software. I guess you've seen it just with example of Touch Designer, how flexible content generation can be. There's so many other options such as Liberation and others, which allows you to generate AVB content. Our transformation is also from getting away from isolated system to our integrated ecosystem. When I'm saying ecosystem, is basically when you buy a LaserAnimation laser projector, you don't only get a physical metal box which outputs light, you get LA toolbox, all those control monitoring options or software solutions as well. For us, the modern production reality is, well, hundreds of devices. For some fixed installs, it can also quickly go into the thousands of devices. So it's a sheer amount of units where you need something to keep trace of and to have a global overview. Modern production reality is also, well, real-time synchronization across laser, video, lighting, audio is becoming more and more required, either through the means of LTC timecode or net timecode, SMPT, and so on. But also we have the need for redundancy, flexibility, and a centralized control. Finally, also demand for creative workflow that go way beyond pre-programmed content. Nowadays, we see more and more interactive shows or creations where finally we have some preset content, but that content will in real time be modified by interactions of people, audience, and so on. As mentioned, our ecosystems delivers you, well, AVB, a reliable, scalable infrastructure. With our AEF and LA tools, a universal content format playback, LA toolbox being centralized network management and control software, and with LA Laser Chop and Touch Designer, well, unlimited creative possibilities. As said, what Moritz just did show you is the tip of the iceberg of what you can do with Touch Designer. And for us, well, the future of laser technology isn't just having brighter laser projectors, more powerful projectors, or faster scanners. It's about intelligent networked systems that integrate seamlessly into larger production ecosystems. Quite often when we laser people arrive, well, the entire network is already set, so we have somehow to get our devices into existing networks, and the idea is use the best available network. That future is here, and we are excited to build it with you. Thank you very much for your attention. If now there are any questions, we would be happy to discuss them with you. And before forgetting, if there are also any questions later, don't hesitate, either send an email to Moritz or myself. On our YouTube channel, LaserAnimation, we have a lot of also quite useful tutorial videos, especially regarding LA Toolbox explained in detail. And for the online tutorial about Touch Designer, what Moritz just mentioned. So that's the link for the Node Institute.
Thank you. Any questions now? Yeah?
Yeah, so if I get it, AVB is quite new for you, but in the audio world, AVB is a quite old standard, and the audio community actually is moving away from AVB. Only my sound is really using it. Are you aware of the other audio standards, and are you looking into them, maybe in the future, expanding to some other standard like Milan or Ravenna, also, which also gives you the BTP, precise timing, synchronization, and also the same latency. So maybe it's actually the same package you get, but in a more comfortable way.
So let me roughly summarize the question for the stream. It was that like some of the audio world is like AVB is quite old for the audio world. We have adapted it for like some years now, but like some of the audio world is moving away to like different standards, newer standards like Milan, and we are definitely also going to Milan, and we have some other customers using Dante with some special devices, and it's basically the same package that you get. Yeah.
It's always when people are asking how many projectors are you selling per year or what type of device, I'm always saying, well, 20% catalog devices, 80% custom made, and that's it. There are so many customers, fixed installs, the ones they want AVB, other ones they want Dante, and so on. So we somehow adapt to customer requirements. Until now, well, we know, as Moritz mentioned, the possibility to go into Milan, but for now, I haven't received any customer requirements or project specifications asking for that. So the main is either Dante, AVB, and you will see tomorrow on our workshop a lot of fixed installs. They try to reduce, let's say, data network to the strict minimum. So during content creation, they are linked through AVB. And once the show is, let's say, set, they just record, put the frame, those IEF files onto laser projectors, and then they just trigger them with a net time code, which is finally also, you'll see tomorrow, it's still very accurate. Or time precise, and it just minimizes data traffic to, I would say, nearly zero. So, yeah. Any more questions? Yeah, Sean.
Yeah. 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 Okay, so the question was whether the LA Laser Job has some fail safety, so you cannot accidentally destroy your scanners. So there are a few aspects to it. Back in the days, the laser job definitely had like unfortunate parameter ranges. So if you would move the step size too far, then it would generate signals that are like making the scanners move definitely too far. We have changed this. Also, all the parameters they don't change if you change the like the scan at the sample rate. Like the signal kind of stays the same. But of course, it's not possible to handle and to make all aspects safe in the laser job, because there is still the transmission between it, and like you cannot achieve like 100% safety on the side of the content generation, because you need to know the characteristics of the scanners, And, but we have also something for it which we are going to talk about tomorrow.
Because the main thing is, let's say you generate an AVB stream, being 5-channel audio. They go through a sound desk or mixer, and if there you do something with this signal before it goes further, or for example on your computer, those things, well, touch designer might generate something which is somehow safe, but what you do afterwards with that signal could lead to unsafe signals for the scanners. So as Moritz mentioned, that's also going to be part of tomorrow's presentation. A couple of things we've been working onto, which also include in basically that whole laser animation ecosystem, getting more than just a metal box, getting functionalities, features, and so on. So I'd say, in my eyes, some unique selling points.
Well, the thing is, the LaserGraph DSP outputs an analog signal. It has like components inside that are just outputting an analog signal, and that's just like the it's like the core, like the whole processing of the LaserGraph DSP happens with some special DSP chips, and at the end it's just an analog result. It's not completely digital, like the signal is not completely digital in the end anymore. So you have to sample it somehow, and that's why you have to use an ILDA to AVB. Yeah, that's the solution for it.
Yeah, well, indeed. Well, if you just have one ILDA to AVB and you have 20 channels, that would be 20 times recording the show. If the show just is 2-3 minutes, it's going to take you an hour. Of course, if the show is 20 minutes, time 20 channels, it's a bit more. Well, luckily, that's also, we do have a small, let's say, rental pool where we can also supply some interfaces. But yeah, the main thing, what makes the DSP output quality is just that, say, combination of DSP chip and those output DACs. So unfortunately, if we would grab the signal before that final conversion, you wouldn't have the same or the known output quality of a DSP. Exactly, yeah. The normalization done on the laser projector himself. So that's why the main idea is if you have several lasers in a room, you want to feed them with one same AVB stream, is having it at 100% on size, on colors. And finally, if one laser is projecting onto a white wall, another laser is projecting onto a blue wall, well, the one going onto the blue wall, you will do your color correction on the unit, on the LA toolbox, and then you match the colors. So it's the same signal. You don't need to adapt just for the unit projecting or on the black wall. That one will need to be changed compared to a laser going on a white wall.
Or it's another example could be if you have recorded the show and it's inside the SD cards, and then one of the projectors slightly shifts somehow because someone was working on the rig, and you don't even have to go up there and like move it manually, or you don't have to like re-record the show. You just go in the toolbox and like slightly move it with your mouse wheel around, and then it's perfectly aligned again. You're welcome.
Okay.
No more questions? Yeah, you can also come to us later, talk to us. And yeah, we're happy to talk to you. Thank you.
Thank you very much.